Welcome! In this video, we shall introduce conditional probabilities. The idea of having a conditional probability is that we would like to know how likely that an event occurs given that we have some other additional information. More specifically, we wish to know the probability that event A occurs while we are given an additional information that event B has occurred. We write the conditional probability of A given B with this notation. Notice again that event B is written after this bar. It means we know the information that event B has occurred or it is assumed to have occurred from the question. Then the conditional probability of A given B is defined to be the probability of A intersects with B divided by the probability of B. One restriction is that the denominator, which is the probability of B, must be positive. This notation is the probability of A given B, and it is a conditional probability. It gives us a value between 0 and 1, and this value reveals how likely that event A occurs given that event B is true. Let's refer to the following Venn diagram as an illustration on why this formula makes sense. We have a Venn diagram representing our events A and B. The rectangle represents the entire sample space omega. We would like to know the probability of event A given that event B has occurred. We are given that event B has occurred, so that reduces the sample space down to just event B. So our total outcomes to be considered is reduced. Now, event B has occurred, so we are within this circle, and then what is the probability of event A has also occurred? Since event A shares this region with event B, therefore the probability of event A occurs given that event B has occurred will be the ratio of the probability of the intersection of A with B divided by the probability of B. Let us refer to the following situation. We have a rectangle with length 10 units and width 6 units. It is divided into 60 squares, each with size 1 square unit. Among them, 20 of them are red and 40 of them are blue. On top of that, we filled 4 red squares with yellow and 2 blue squares with yellow. So there are 2 colors on these 6 squares. Now suppose we pick a square from this rectangle by random so that the chance of picking each square is equally likely. We wish to find the following probabilities. First, we want to find the probability that the square we pick has yellow color on it. Part B, we want to find the probability that the square we have picked has yellow color on it given that the square we pick has red color on it. And part C, we would like to find the probability that the square we picked has yellow color on it given that the square we pick has blue color on it. For part A, we notice that the chance of picking any square is equally likely, and we have no further information we got other than this information. Therefore, among all the 60 squares, 6 of them contains yellow color. Therefore, the probability that the square we picked has yellow color on it will be the total number of squares which has yellow color on it over the total number of squares in this rectangle. This gives 1/10. Part B, We want to find the probability that the square has yellow color on it, given that the square has red color on it. So we have already got the additional information that the square we pick has red color on it. According to our definition of the conditional probability, the probability of yellow given red is equals to the probability of the intersection of yellow and red, that is, probability of yellow and red, divided by the probability that the square has red color on it. So, first, the probability that the square has both yellow and red color is 4/60, because among all the 60 squares, 4 of them contains both yellow and red. And the probability of red is equals to 20/60, because among all the 60 squares, 20 of them has red color on it. It is equals to 1/5. And you can see that if we cancel out the 60, it is also equals to 4/20. And it means that we have restricted our attention to those 20 red squares, and this is our reduced sample space, and among these 20 squares which contains red color on it, 4 of them also have yellow color. Therefore, this conditional probability is also equals to 4/20, which is 1/5. Part C, the conditional probability of yellow given blue, according to this formula, is equals to the probability of yellow intersects with blue, that is, the probability that the square contains both yellow and blue colors on it, divided by the probability of blue. So, the probability that the square we pick has both yellow and blue color on it is 2/60, because among all the 60 squares, 2 of them has both yellow and blue color on it. Whereas the probability of the square to have blue color on it is equal to 40/60, because among all the 60 squares, 40 of them have blue colors on it. Therefore, this gives 1/20. And you can see that it is also equals to 2/40, and this means that since we know that the square we pick is blue in color, therefore we have now narrowed down our attention to those 40 squares which contains blue color on it, and among them, just 2 of them also contains yellow color. Therefore, the conditional probability of yellow given blue is also equals to 2/40, which is equals to 1/20. Now, let's refer to the same situation, but we would like to find the following probabilities. Part A, we would like to find the conditional probability P of red given yellow. And Part B, we would like to find the probability that the square has blue color on it, given that the square has yellow color on it. Please be reminded that the chance of having each of the square is equally likely in our situation. Now for Part A, according to this formula, the probability of red given yellow equals to the probability of yellow intersects with red, that is the probability of both yellow and red, divided by the probability of yellow. For this probability, it is equal to 4/60 because among all the 60 squares, 4 of them has both yellow and red color on it. And for this probability, the answer is 6/60 because among all the 60 squares, 6 of them contains yellow color on it. Therefore, this gives 2/3. We can also think of it as, first of all, we are given that the squares has yellow color on it. Therefore, instead of considering the whole sample space, we only restrict our attention to these 6 squares which has yellow color on it. And among these 6 squares, we want to find how likely that this also has red color on it. So among these 6 squares, only 4 of them also has red color on it. So the probability will be 4 over 6 because each square comes out equally likely. Therefore, the probability is 4 over 6, which gives 2 over 3. Part B, we want to find the probability of blue given yellow, and by this formula, it is equals to the probability of having a square which contains both yellow and blue color divided by the probability that the square contains yellow color. Now, this probability is equals to 2 over 60 because among all the 60 squares, 2 of them have both yellow and blue color on it. Whereas, for this probability, it is equals to 6 over 60. And therefore, the probability is 1 over 3. And we can also think of it as, first, we are given that the square contains yellow color on this. Therefore, instead of referring to the whole sample space, we only put attention to the 6 yellow squares here. And picking any one squares among these 6 squares are equally likely. And because just 2 of them contains also blue color, therefore the probability that the square contains blue color, given that the square contains yellow color, will be 2 over 6, and this gives 1 over 3.